I'm going to tell you 2 facts that I'm sure you already know. The first is that the Earth revolves around the Sun, and the second is that just as the Earth gravitationally attracts us, so the Sun gravitationally attracts the Earth. You knew that, right? So here's a question for you. If the Sun and the Earth attract each other, why doesn't the Earth fall? Why hasn't the Sun swallowed it up? What's stopping it? If you don't know why, don't sweat it, because I'm going to tell you something that will blow your mind. The answer is that the Earth is falling. And it's not falling slowly, it's moving pretty fast. The magic is that the fall fails. This will make it crystal clear. Imagine I take the Sun and the Earth and just set them in space. What will happen? They'll attract each other and eventually collide. But what if I give the Earth a little flick to the right before letting go? Well, the Earth will still be drawn to the Sun, but it'll drift to the right along the way, impacting at another spot. Depending on how hard I flick it and the direction of that impulse, I can control where the Earth will hit the Sun. But wait, what if I flick it hard enough to set the Earth on a path that avoids the Sun? What would happen then? Well, the Earth would still fall toward the Sun like before, only this time the collision would fail. The Earth would shoot past it, travel to the other side of the Sun, and then return, dodging it again. This peculiar way of falling and never landing is what we all know as orbiting. Orbiting is basically falling. It's being accelerated towards an object, but at just the right lateral speed to avoid hitting it. Let's take a closer look. Thanks to our little push, the Earth has a certain lateral velocity. And if it were up to Earth, it would continue traveling in a straight line in that direction. However, the Sun exerts a force of attraction on the Earth, pulling our planet toward it. This pull is what makes the Earth veer off course, shifting its trajectory sideways. At the next step, the Sun attracts the Earth again, altering its path once more. The Earth wants to travel in a straight line, but the Sun is constantly forcing its trajectory to curve. In other words, the Sun's gravitational pull on the planets is what keeps them revolving on a stable course without leaving their orbits. And gravity isn't the only force that can do this. The tension of materials has the same effect. All of these forces capable of curving straight trajectories are called centripetal forces. Realizing this was one of Mr. Newton's biggest breakthroughs. He understood that both an apple and the moon are falling. Only the moon has the very good fortune to be moving sideways fast enough that it never hits the ground. And here's another question for you. Who gave the Earth that little nudge to prevent it from crashing into the Sun? The answer? No one. It was born moving that way. The solar system emerged from a huge cloud of matter which, thanks to gravitational force and tons of collisions, managed to form a disk revolving around the Sun. Over time, the matter in that disk condensed, forming the planets and other bodies, each moving at the proper speed. Revolution is their factory setting. Basically, guys, orbiting is falling. The space station falls, satellites fall, and the moon falls. It's super important that you get this if you want to understand how crazy general relativity really is. But we'll see that in another video. And remember, if you want more science, just hit the subscribe button. Thanks for watching.